Okay, in the last video, we discussed drawbacks of Rutherford atomic model. There are two main drawbacks of Rutherford atomic model. In the first one drawback of this model is, this is the drawback, okay, of Rutherford atomic model. RA means Rutherford atomic model. The first drawback is, according to this model, there are infinite numbers of orbits, okay, around the nucleus, and electrons can rotate in any orbit of any radius. This was not true, because once we move to the Bohr models, then we will explain it there that why electrons cannot revolve in any orbit of any arbitrary radius. There is a specific orbit in which electron can revolve, not in all orbits. And the second drawback of this model was that the electron is continuously accelerating, okay, towards the nucleus, towards the center. So if this is the case, if electron is continuously accelerating, then what it means? It means that the electron is also continuously emitting electromagnetic radiations. This is according to the theory of electricity and magnetism. If a particle is accelerating, then it will emit radiations, and the radiation is in the form of electromagnetic radiation. So what it means? It means that the electron, which in this case will continuously lose energy, because if it's emit radiation, what it means? Electron will lose its energy. So once electron loses its energy, then the electron will fall into the nucleus. When electron will fall into the nucleus, when electrons lose all of its energy, then finally it will fall into the nucleus. So what it means? It means the whole atom will be destroyed. It means the whole atom destroyed in 10 raised to power minus 8 second of time. These are the two drawbacks of this Rutherford atomic model, which I also discussed in the previous video. Now, to remove these drawbacks, to remove the deficiencies of Rutherford atomic model, Bohr introduced his own atomic model. So here I will explain the Bohr's atomic model. Now Bohr made few postulates on the basis of quantum theory, or he made few postulates on the basis of quantum theory. And he made these postulates for the explanation of atomic spectra and stability of atom. So the first postulate of Bohr atomic model is the electron move around the nucleus. This is the first postulate, that the electron move around the nucleus in circular orbit. Due to an electrostatic force of attraction. So the first postulate of Bohr theory was that electrons, here we have the nucleus at the center, and electrons are moving or revolving around the nucleus in circular orbit, and this movement of electron in this circular orbit is due to this electrostatic force of attraction which is between the nucleus and the electron. Like this nucleus attract this electron toward itself by a force which is called the Coulomb force. Now, if this is the only force, then what will happen? This electron will fall into the nucleus, but according to this theory or this model, electron move continuously around the nucleus in circular orbit. So it means that there is another force which stop this electron to go into the nucleus, and that force is called centrifugal force. So for this I call it electric force, and this is called the centrifugal force. So here I can say that this electrostatic force is balanced by the centrifugal force. Acting on the electron due to its motion. So here I can say that according to this postulate, the first postulate, the force of attraction or the electrostatic force is balanced by the centrifugal force. And we know that the electric force is, we have the electric force is, or the Coulomb force is, we have K, Q1, Q2 over R square. So here Q1 is the charge of the nucleus, which is ZE, and Q2 is the charge of the electron, which is E, and distance is R. So we have K ZE E divided by R square, which is equal to the centrifugal force, which is equal to mv square over R. This is the first postulate of Bohr theory. Now the second postulate is electrons revolve around the nucleus only in those orbits. Electron revolve around the nucleus only in those orbits in which the angular momentum is an integral multiple of h divided by 2 pi. What it means? It means that only those orbits are permissible, electrons revolve only in those orbits in which the angular momentum of the electron L is equal to integral multiple of some constant, which is n, times this factor h divided by 2 pi. Now we can say that L is equal to those orbits in which the angular momentum is equal to nh over 2 pi, then electron revolve only in this orbit. If L is not equal to nh over 2 pi for an orbit, then there will be no electron in that orbit. So only those orbits are permissible for the motion of electron in which the angular momentum L is some integral multiple of h over 2 pi, where n is a constant and its value is n is equal to, its values varies from 1, 2, 3, so on, and we call it principal quantum number. Now we know that angular momentum is basically r cross p, the cross product or the vector product of position and momentum. But we know that in case of circular motion, if this is the circular motion of electron, if this is the electron which is revolving around this nucleus in circular orbit, then this is the radius and the momentum of the electron is given by this one at this point. This is p. Here we see that the angle between momentum p and this position vector r is 90. So if angle is 90, then we have this L which is equal to rp sine 90, which is rp, and we know that p is equal to mass times velocity. So we have rmv. So overall we can say that L is equal to mvr. So we can also write this equation like this, like electrons revolve only in those orbits in which the angular momentum, so angular momentum, for angular momentum I will directly write this mvr is an integral multiple of h over 2 pi, where n is a constant, its values varies from 1 to 3 and so on, and it's called principal quantum number, and h is called Planck's constant. And its value is 6.626 and 10 raised to the power minus 34 joule second. So this is the second postulate of Bohr theory. Now the third postulate is, we have the final and the third postulate, which is the third postulate is no energy is released as far as the electron remains in any one of permissible orbit. what it means? It means that if electrons are revolving in this orbit, this is the permissible orbit, okay, this is the nucleus, this is the electron which is revolving in this orbit. So as long as electrons revolve in this orbit, it does not emit or absorb any kind of radiation. But when electrons jump from, if this is the nucleus, this is the first orbit, this is the second orbit, this is the third orbit, okay. So when electron jumps from one orbit to another orbit, so I can say that when electron jump from one orbit to another, then what will happen? It will emit or absorb energy in the form of radiation. So when it will emit radiation and when it will absorb radiation, suppose we have an electrons here, okay, when it jumps from this orbit, this lower orbit, to this higher orbit, okay, then what will happen? It means that some energy or radiation it will absorb, and due to this absorption it will jump from this orbit to this one. So here I can say that if this is the energy of the final orbit EF and this is the energy of the initial orbit EI, okay, because initially the electron was here, finally the electron reached to here. So it means that the energy or the radiation absorbed by this electron, which is h nu, this is the energy of radiation, okay, energy of electromagnetic radiation. So the electromagnetic radiation absorbed by this electron, due to which this electron move from lower orbit to higher orbit. So this is the initial and this is the final energy. When electrons jump from when electron jumps from higher energy states orbit to lower energy state or orbit, like if electron jump from higher energy states, a higher orbit to a lower energy state, a lower orbit, what will happen? It will emit energy in the form of electromagnetic radiation. So here suppose the electron was initially here in this orbit. This is the initial state of the orbit, initial energy of the electron EI. When it jumped from this higher orbit to this lower orbit, electron in this final state EF. So due to this jump or due to this transition, electromagnetic radiations will be absorbed. So here we have this h nu. This is the energy of electromagnetic radiation. So the energy of electromagnetic radiation absorb will be equal to emit will be equal to the difference in energy of the two orbit, EF minus EI. We can calculate the final energy of the electron. The electron energy in the orbit after transition will be equal to h nu plus ei. That the energy in the higher energy states plus the energy emitted in the form of electromagnetic radiation will give us the final energy. This was the third postulate of Bohr theory of hydrogen atoms, a Bohr theory. So in the next video I will discuss spectrum of hydrogen atom. Thank you.